All right, so this is part 3 of our review for our end of course exam. Number 22, we need to find the x and y intercept. So the first thing we need to do is actually write our equation how many times? Twice. One for the x-intercept and one for the y-intercept. All right, and if I'm solving for x, does anybody remember what am I supposed to plug in for y?
0.
0, because I can't have two variables in the same equation. Okay, so when I plug in 0 for y, what happens to y? It's gone. It cancels out. Okay, so now I have 2x equals 40. What do I do now? Subtract?
No, you divide.
Divide by 2. X equals 20. All right, so now on the flip side, on the second one, if I want to solve for y, I plug in 0 for x, goes away. That's what I need. And then what do I divide both sides by? -4. -4, both sides. Y equals -10. Did you guys get that?
Yes.
Now, do they come together to make one ordered pair? No. This is one ordered pair. This is a second ordered pair. That's 2 points. All right, now let's look at number 23. Here's the question we always have to ask ourselves. Is this equation ready to graph?
No.
No, it is not, because the 3 is attached to the y. So how could I get the 3 to cancel out but the y to stay?
Divide by 3.
Divide by 3 both sides. And now I have to reduce. This is 2x, -2x plus 3. Now the -2, what could I put it over? Just to remind me. I put it over 1, and why would I do that? Rise over run, okay? Where does my first point go on the graph?
Positive 3.
Up to 3, and then where do I go from there?
Down 2 over 1.
Down 2 over 1, okay? So guys, this is really core, foundational to algebra. So in all of pre-algebra, when we learned linear equations and functions, which we're going to talk about in a minute, that is like the heartbeat of what we need to know going into Algebra 1. This is really, really important. All right, so now looking at number 24. We're going to skip over number 25 for today, and we're going to cover it tomorrow. 25 gets a little bit more involved, and I just want to focus on the other problems for today. Okay, so on number 24, all right, here's what I want to do first before we even solve anything. 24, 26, and 27. I want you to remember, what is your end goal for all 3 of these? Now, you're given different information in each one of these problems, but your end goal is to write an equation and to fill in the information into slope-intercept. So here's what you're trying to solve for. The y is a part of your formula. The m you don't know. The x is a part of your formula. And the b you don't know. Okay? So with each one of these problems, you're trying to solve for m. M stands for what? Slope. And you're trying to solve for b. B stands for what? B stands for the y-intercept. What does y-intercept mean?
The up and down on the
But where what intercepts it? Where the line crosses the y-axis. What value does the line cross the y-axis? That's what we're trying to solve for in all 3 of these problems. Now, on each of them, they give me different information. On the first one, they give me 2 ordered pairs. Well, can I use 2 ordered pairs to find slope? Does anybody remember the formula? y2 minus y1 over x2 minus x1. Okay, so that was great participation. Just as a reminder, your participation grade is what's going in the grade book. So these questions that I'm asking you, you're getting participation grades for it. If you're sitting there kind of just picking out your pencils and you're not really doing much, you're not participating, okay? All right, so great job on that. All right, so our formula and our sequence. I'm actually on the wrong slide, but our sequence is important. Whoops. Hold on, let me back up, okay? Do you guys remember the sequence? x1, y1, x2, y2. That tells me which number goes where in my formula. Go ahead and plug in these numbers and solve for your slope, please. Go ahead and plug in these numbers and solve for your slope. All right, and I'm on the right slide now. Okay, go ahead and plug in these numbers and solve for slope. Remember, you're trying to figure out the value that plugs in for m. Okay, so what goes in the numerator? Say it with me. 8 minus 4 over 3 minus 0. So that's 4 over 3. So, well, Ms. Kinder, this is something, when I took this test, I did not understand this. I got it wrong on my test. Does that mean you're automatically going to get it wrong on the EOC? No. No, you still have a chance now to learn it. Okay? It's really, really important. So I know my m value, y equals 4/3 x. But now I need to know where the line is crossing the y-axis. Does anything in the original ordered pairs possibly give that away?
Oh, yeah, the one with the 0.
Yes, the one with an x value of 0, because that means it doesn't go left or right any for the point. It just goes up to a 4, and you plot your point. So the line crosses the y-axis
At the 4.
at the 4, at the positive 4, because 4 was positive in the ordered pair. Okay? Now, go down to number 26. On 26, now I have a graph. Can you find slope just using a graph? Does anybody remember that formula? Rise over run. So could you pull out the ordered pairs and do a repeat of number 24? Yes. But why would you do that? By the time you even just write down your ordered pairs, I'm already going to know the slope. Okay? Just counting rise over run. And then you can look at the graph and actually see visually where the line is crossing the y-axis. That's your b value. All right? Go ahead and write your equation. So how many did it rise? 3. 1, 2, 3. How many did it run?
5.
1, 2, 3, 4, 5. So y equals rise over run, x.
Plus 2.
How'd you know it was plus 2? Why not plus? Yeah, because that's where the line crosses at a value of 2, plus 2. Okay, so now on the next one, over here you have a table of values. When you have a table of values, you could essentially choose the first 2 ordered pairs, the second 2 ordered pairs, the last set of ordered pairs. It doesn't matter. Any of these ordered pairs are going to give you the slope. Here's what I'm going to tell you to do, though. Do not try to label them inside the table. Say, oh, well, this is my x1 and this is my y1, x2, y2. You're going to get it confused. Okay? Say, well, no, I can keep it straight. I checked several papers today where they did not want to actually write the ordered pairs, and they got it wrong because they wrote the wrong numbers. So pull out the ordered pairs. -3, 1. 0, 3. Okay? All right, and now find your slope, and one of the ordered pairs is going to give you a hint as to what the y-intercept is. All right, so pull them out, find your slope and your y-intercept, and write your equation. All right, 3 minus 1 is 2, 0 minus -3, 3, 2/3. What is my y-intercept?
3.
How did you know it was 3? Because it's paired with a 0 for x. Okay? You guys going to get this right? Okay? It's really, really important. All right, so now we are going to pass over your systems of equations, numbers 28 through 33. We're actually going to do those tomorrow. And we're going to pick up on number 34. All right, so go ahead and turn in your review sheets to number 34. Number 34 in your review sheets. Okay, I want you to identify A, B, and C on the graph as a cluster, an outlier, or a gap. Go ahead and do that real quick. What is A? What is B? What is C?
Outline.
Yeah, and what is C? No, C is a gap. C is a gap. All right, there's points. I mean, it's kind of a stretch to see. Probably could have been moved down a little bit farther, and that's a bigger gap. But we're just identifying what's a cluster, what's an outlier, what's a gap. What does this mean? This means that on A, most of the data is clustered down in that region of the graph. On B, that's a value that's just way outside the trend of the other values. And C, a gap is exactly what it sounds like. It's a gap in the data. All right, let's look at number 35. Number 35, guys, there's so much packed into number 35, and it is on your EOC. You need to star it. You need to star it for number 35, where you're going to make a scatter plot. So on your test, you're going to have a blank graph that looks just like this. And then you're going to have a table of values. This table of values tells you generally what values need to be on your scatter plot. So for my X values, would I put 10, 20, 30, 40, 50? No, because that doesn't outline what my actual X values are. 1, 2, 3, 4, 5, 6, 7. So what do you think you're going to number your X values by? Yes, by ones, of course. All right, but what about your Y values? Are you going to number them by ones? No, 5s is way too big because you would only have like 3 intervals. Okay, I would go by 2s. 2, 4, 6, 8, 10. Go all the way up. Okay, we're not going to go all the way up on plotting the points, but the line of fit may actually go up a little bit higher. So now I need to know where I'm going to plot my points. So I'm looking at the graph, and I think a point would look really cool, like right here. Is that how I'm supposed to set up a scatter plot? Just put the point wherever I feel like it?
No.
Well, what tells me where to put my points?
Table.
The table, right? Okay, so even my quiet ones, you guys are paying attention, right? So my X and my Y value together make up the coordinates for my first point. So I go over 1 on X and up 15, right halfway between 14 and 16, and I plot my point. So go ahead and do that for each of the other ordered pairs. Okay, you should have all of these points on your scatter plot. Then we're going to talk about what these points mean. Okay, so here's my other points. Okay, let's talk about this in terms of X and Y. What can you tell me about how X and Y are related to each other? What can you tell me about their relation? X and Y. As X is increasing, what is happening to Y? Y is decreasing. So now let's name the categories. What category stood for X? No, what category? Weeks. And what category stands for Y? Losses. What is this talking about? What is this talking about?
Every week you miss, you lose.
No, look at the number 35 next to it. The table shows the number of losses, which is Y, a gamer has after getting a new video game. Okay? So, what does this mean? Now let's go back to the first point that we plotted. What is that first point telling me? After how many weeks?
1 week.
He has 15 losses. Okay, so after 2 weeks, he has 12 losses. So now tell me, what does this pattern show me about the gamer?
That his losses are decreasing.
Okay, I heard the longer
he waits,
the longer he owns the game, right? What's happening to his losses? He's getting better. He's getting better, right?
Yeah.
At the game, because he's losing less. Maybe it's like NBA or something. I don't know. Yeah, 2K. What is it now? 2K19. Okay, so doesn't that make sense too? Like when you first get a game, anybody ever been really bad at something when you first try it? Yeah, and then the longer you have it, the better you get. Okay, so we're going to talk more about this tomorrow, and we're going to do your line of fit tomorrow. Okay, so this ties straight into number 25, which we also skipped. Okay, so we're going to revisit the rest of this problem tomorrow. For now, we're going to go ahead and move on to number 36. Okay, so we did our scatter plot. We'll do line of best fit tomorrow. Let's go ahead and look at number 36 now. Making a two-way table. A two-way table means I'm comparing two categories of information. Okay, so you might be wondering, well, which order do I set up? It doesn't matter, okay? Your column can be one of the categories, and then, each thing in that category, and then the other column across the rows can be the other two. All right, so for me, I did male and female, okay, on the left side. And what categories do you think is going to go across the top?
Total.
No. What other category?
Pets.
Not pets. I need two.
Cat.
Cats and dogs. Cats and dogs. Okay. So now what I need to do now is go back to the data. How many males own a dog? How many males own a cat? Female dog, female cat, and then calculate my totals. Leave the bottom right block open for now. We'll talk about that in a minute. All right, but the hardest part about a two-way table in your end of course exam does not give you this template. They just say make a two-way table, and you're going to have to do it on your own. Okay? Now, I could have switched dogs and cats and male and female. I could have switched them. It's not a big deal at all. Okay? Go ahead and fill in your data and your totals. And while I'm thinking about it, that's what it means by marginal frequency. That's a fancy word for total. Okay? When it says marginal frequencies, that's just totals. That's all that is. Yeah, it's a fancy word for total. How many males own a dog?
17.
How many females?
14.
How many total?
31.
How many males own a cat?
8.
Females?
20.
Total.
20.
All right, so now let's total across. How many males own a pet, period?
5.
And how many females?
34.
So here's what's going to happen, guys. If you've done the two-way table right, what's 25 plus 34?
59.
What's 31 plus 28?
59.
Both numbers will add up to the same number in the bottom right-hand corner. Okay? You going to get this right next Wednesday? Okay. All right. So now let's do functions. You need to write this down next to functions. A function is this. Has one input, each input has one output. That's what you need to write. Each input has one output. All right, so the input value is X and the output value is Y. So each input, each X value, has one output. It has one Y value. All right, you need to star number 37. It's on your EOC. Okay? It's going to give you a set of ordered pairs. A set of ordered pairs. And it's going to say, do the ordered pairs represent the graph of a function? Here's how you tell. I want you to go through. Which value did I say was input? Is it X or Y? X. Underline every X value in the ordered pairs. Go ahead and underline them. As you're underlining them, do any of them repeat? Okay, as you're underlining them. So I go 3, 2, 5, 8, 5, and 12. So which one repeats?
5.
So there's my first red flag. If I see an input value repeat, the output values have to be the same in both ordered pairs. Are they the same?
Nope.
One is 19 and one is 14.
No.
So it's no, it is not a function because the input 5 has outputs of 19 and 14. All right? So here's what we're saying. If you plug a number into an equation, you're going to get one answer. Okay? So if I plug in a 2 in for x and the function is y equals 2x, 2 times 2 is 4. It cannot be any other number. It is just 4. Okay? But here's a scenario where it would not be a function, but it's still a relation. How many of you are 13? How many of you are 13? Raise your hand. Are you all, listen, if we were to put all of your age and height into an ordered pair. Okay, so I have what, 7 people in here, 8 people who are 13. Are you all the same height?
Nope.
No, you're all different heights. So your input value is your age. You said that, maybe 7 of you are 13. So you're going to have 13s for all your X values, but you have different heights. Does that make sense? Okay, so in that case, it doesn't mean that you can't graph that. You absolutely still could graph those ordered pairs, but it's not going to be a function. Okay, all right, so in some scenarios, you can have ordered pairs. It's just, are they a function or not? All right, look at number 38, the mapping diagram. All right, that's what we see over here. Given our criteria, does each input have only one output? So it's a function. Okay, and then what you're going to do is you're going to pull each one out and make it an ordered pair. All right, so we can say them together. -8, -5, -6, -4, -4, everybody, -3, -2, -2. And yes, it's a function. Okay, so 39 and 40 should look pretty familiar, don't they? Okay, good. If you've already done them, I'm going to come check. But they should look pretty familiar. It looks just like a linear equation. It pretty much is, but all I'm saying here now is that it's a function, that each input had one output, yada, yada. You still graph it the exact same way. All right, so let's work on 39 and 40. One is set up to graph. The other one is not ready to graph. All right, we have to work on the equation a little bit. All right, so for the first one, guys, where did my first point go in number 39? Just tell me. Where did my first point go?
2.
2, and then where do I go?
Up 3 over 1.
Up 3 over 1, draw my line. All right, now on number 40, what did I have to do first before I could graph?
Divide everything by 6.
Divide everything by 6. And now I get y equals 1/3 x plus 3. So where does my first point go?
3.
On the 3. And where do I go from there?
Up 1 over 3.
Up 1 over 3. Okay, and there goes my line. And that's going to be everything we cover for part 3.